All right, class, in this lesson we're going to be taking a look at section 1.2, where we're going to be dealing with inductive and deductive reasoning. So let's talk about some of these problems. We've got inductive reasoning, which involves looking at patterns and making a hypothesis based on general conclusions based on specific instances that we've actually observed. And then we look at our deductive reasoning, which uses accepted facts and arrives at a specific conclusion. So let's take a look. We've got fingerprints of 3,000 people. No two individuals in this group have identical fingerprints. We conclude that for all people, no two people have identical fingerprints. So the question is what type of reasoning is this? Is this inductive, looking at a pattern and then making a hypothesis? Or is this using accepted facts and general principles to arrive at a specific conclusion? So being that we're actually looking at a sample of 3,000 people and making this observation based on the pattern that we've seen, we're looking at inductive reasoning. Although you could have said it from the beginning, I didn't look at anybody's fingerprints, but I already know a fact, and the fact is that nobody is going to have the same fingerprint. That would be deductive, but here in this specific example, this is looking at inductive reasoning. So our answer is inductive here. Okay, so, sorry, I asked the question there. We've got our definitions up top still, and then the job is to determine what type of reasoning are used in each of these different situations. So there's three different problems here. Problem 1, Mary Ann. Problem 2, we've got Letitia. And then problem 3, we've got Brett. So Mary Ann is using the rules of algebra to solve a word problem on a quiz. So this one uses patterns? No. We've got rules. And so that's dealing with accepted facts and general principles. So straight up algebra is using deductive reasoning. Okay, Letitia noticed that on every true or false quiz so far this semester, her instructor has given twice as many false questions as true questions. On the next quiz, she is not sure of an answer. She will guess false because more likely he's giving false questions. So now, is that a accepted fact? Is he always going to have twice as much? No, it's just something that she has noticed through a pattern in specific instances of our past tests. So this is a inductive reasoning. Okay, Brett is calculating his expenses for the next year to determine how large his student loan should be. Now, this is dealing with it's kind of hard because you're dealing with his past behavior, his past patterns of how he's been working, but again, it's a little bit harder problem because yes, he's working on his patterns from last year, but because he's looking at student loans, he actually knows for a fact what his expenses are. It's accepted of how much it actually costs to go to school. So here we've got deductive reasoning. And that one's hard because when you're budgeting, you're using inductive reasoning based on what you've done before, whereas here we know our expenses, and so it's deductive. So here it says use inductive reasoning to predict the next term in a sequence. Now, here we say inductive reasoning because this last number technically in math could be anything, but inductive reasoning leads us to follow the pattern of behavior that we observe. So here we see 1 turning into a 4, 4 turning into a 7, 7 turning into a 10, 10 turning into 13. So I want to see what's happening here. Well, I'm adding 3, add 3, add 3, add 3. So each time I'm adding 3, so guess what the next one's going to be? I would imagine if I add 3, the answer is going to be 16. Okay, so it's working with our understanding of inductive reasoning to do these sequences. So we'll take a look here at another one. We've got 1, 1, 2, 3, 5, 8, 13. Well, at first you're like, well, shouldn't we have repeated 2, 2, 2, 3, 3? Well, it doesn't go that way. If I look closely, notice the 2 comes from adding these. The 3 comes from adding these 2. The 5 comes from adding the 2 before. The 8 comes from adding the 5 and the 3. So each number is coming from adding the 2 previous numbers. And so in this case, I want to get this next number by adding 8 and 13. If I add 8 and 13, I should get 21. So this next number is going to be 21. That one's a little bit harder to see, and there's even a little bit more challenging one in your homework. So here we've got 0.1, 0.10. Technically nothing changed here, by the way. 0.101 0.1010, and then 0.10101. So the next one, notice each time you're adding a 0, and a 1, 0, and then here we have a 0, and then we added the 1. So here we're going to take 0.101010, and then of course the next one would have a 1 at the end after that. Now we keep doing this type of reasoning on figures. Now here we want to notice what's happening between our first shape, the next shape, the next shape. Now notice this circle is the thing that's changing. The big circle is staying the same. This circle moves inside right here on this next picture. Then it moves back out over here. Now my thought is it's rotating a quarter turn and it goes inside, gets solid, rotates a quarter turn, goes outside, and gets open again. So my imagination says the next one's going to go inside and turn solid. So I would pick a shape that looks like this to be my next pattern, next figure in the pattern. So take a look down here. I've got an X in this top left corner, and it jumps down to the bottom right. How'd I go there? Looks like it went straight diagonal. Then it goes from this bottom corner straight into this box to be right here. So my imagination says it goes diagonal, then it shifts across. So my imagination says the next step would be diagonal, and then across. So my guess would be that the next one would look like this. So let's look at some more patterns here. We've got a hexagon with a diagonal here, and it looks like it rotated so that it would turn here. So it looks like this whole shape just rotated. So we went from here, now diagonal, and then it looks like it rotates the same amount. Notice it rotates 1, 2 lines to be here. And then it does the same thing again. If I am looking at this one, it's going to rotate 1, 2 lines to be up top. So it went from here, 1, 2 to be up top. So that means I'm going to rotate to this next shape and draw a terrible hexagon for you. It looks like it's going to go 1, 2 more shapes. So I go from here, 1, 2, and this is where my diagonal is going to be. So it's going to be straight back to the first one again. So this is the shape that I would pick. Okay. Now notice down here we got a box again. So I go D, D, G, G, D, G, G, J, J. Okay. So now we've got to figure out. I'm guessing we're going to be looking at a box, of course. So our job is to figure out what is going on in this last box. Well, how's the pattern going? And if we're noticing it's our alphabet, so we got D, E, F, G. So we skip. So D, E, F, G. So we go from D to G, and then H, I, J. So we skipped H, I, and went to J. So it looks like we're skipping 2 letters and then getting another letter. So D, E, F, G, H, I, J, K, L, M would probably be the next letter I'm working with. So I'm definitely going to have D, G, G, and then J, J. And then the hard part is figuring out why we have 2 G's and 2 J's. Why isn't it 3 J's? I would have imagined it would have went 3 J's. So I'm going to have to do a little bit of guessing here, but it looks like you started with 1, the next one starts with 2, and then we've noticed how the set, well, that was the third step. So step 1 had 1, step 2 we added 2, step 3 we started the box with 2, but I'm imagining that the next one I'm going to fill it up with 3 M's. So I would replace it. My best inductive reasoning would put an M here, here, and here as a list. Because here I went from 1 at the top of the box, add 2. Here I've got 2 at the top of the box. That means I'm going to go ahead and add 3. So that's to be the shape that I would be looking for as my best inductive reasoning.